Couchbase 103, and we're going to be covering, like Franco said, differences between um, relational databases in Couchbase, understanding documents. We're going to go through some very common key patterns, and we're going to talk through a lot of different things. I will make some room for questions sometime in the middle, and then of course at the end. You can always contact me with additional questions at justdeep@couchbase.com, and my Twitter is @scalable. And of course, any questions that are asked during this session, if we don't get to answer them live during the webinar, I do a follow-up blog post where I answer every single question in a bit more detail, and you'll receive a link to that when you get a link to the presentation and slides. So let's get started. I like to kind of give a quick intro to development because I think that modern developers are sort of a interesting, we are faced with a lot of interesting new paradigms that we have to deal with, and I think that Couchbase solves a lot of these and makes a lot of these common problems a lot easier. And so this was sort of the modernist view of the brain and the world, and that all we had to do was figure out how all the pieces fit together, and it would be this nice perfect world, easily mapped out. Once it's just a matter of time where we map out all these jigsaw puzzle pieces and put them together, and then the world is completely described. But what turns out, and this was prior to the early 20th century, what turns out was that we call the postmodern mind. In reality, everything's relative and really interconnected, and you can kind of see the internet here, and this is what the world is actually more like, with a lot of different relationships, and it's all relative to each other and interconnected. And I think that the real developer brain is a little bit more like this. There's just a lot of things going on. We've got all these different services that we're trying to consume. We're trying to integrate all these things together, through APIs, etc. And to build a new application, we're actually synergizing between many different applications at the same time, along with building our own value add on top of it. So with all these integrations, you get a lot of different types of data. You're working with JSON a lot, and I think that this is where sort of the NoSQL space, started growing, along with the scalability issues that happened in the early 2000s. So I like to I like to call this the kind of post-modern day, where we have huge amounts of data and scalability, unpredictable audiences, virality, and all these things. All these integrations make development a little bit more involved than just writing a single application that's isolated on its own, running locally on a machine like a Microsoft Word or something where you install it off the CD. Nowadays, we're doing all these things that involve so many different applications and data moving back and forth all over the place across the internet. And I think that that's where we can start seeing some of the differences between working with relational and working with Couchbase, is when you start dealing with all these sort of consuming of data and being a source of consumption as well. Working with JSON, pretty much that's the predominant sort of data transfer format. You actually have a strong advantage when you're working with something like Couchbase over relational. So let's talk about some of those differences. So in relational databases, we all know very well that it's organized as tables, and tables represent data in rows, and we have n columns of n rows in every table. The table rows have a specific schema, and this is the important part, and each column has that static type. This allows you to actually do very readily simple data types, string, numbers, date types, booleans, and you can represent those as. But what gets very difficult is when you have complex data types, and our object models tend to have a lot of complex data types where we have dictionaries or hashes or arrays and lists, or lists of dictionaries or dictionaries with lists in them, and that actually cannot be represented in a single table. That's what we call impedance mismatch, or Martin Fowler coined that term, where your in-memory data structures, your objects, have a specific format, or a format which involves all these relationships within it, lists and dictionaries, etc. It's complex, but then when you have to store it in a relational database, it no longer matches that format. You have to break it apart into pieces through normalization, and now you have to have multiple tables to represent that same object. That in memory you have one form, and then on disk you have another form. So the important part is that all your rows also have to have an identical schema, and this schema change requires taking the database offline, making the alter table, possibly if it's a ongoing application, making a migration, and this is all a massive pain. And in organizations that have established applications, uh, this process is actually also a political process. Uh, you know, political, process as well as, technical process in order to change that. And it also brings your application down. So now you have application downtime while you do this change. And of course, there's, the mutex locking on reading and writing. And transactions in relational, also, slow down relational databases. And because of normalization, you need joins. You need to join that to data together. And because of that, all those tables have to be on the same server. So distributing data is very difficult. And in the early 2000s, when the internet started, really growing as, the way to build applications and no longer, send out or buy CDs and install applications. Now, in the early 2000s, all those applications started moving online. It, this necessity of having all the tables on a single relational server made things very difficult to scale. So, in those early 2000s, the things that you had to do to relational databases was turning them into NoSQL databases. Basically, you had to denormalize your data and reduce your joins in order to get performance. And of course, you would do things like put memcached in front of it, to reduce the number of queries on the relational database as well. So those combinations together start seeding these ideas for a NoSQL database. Basically, what the relational started looking like when you had to scale it large. So um, it is a document store, so of course we can still store all the simple data types as straight values. And then we can also store complex data types. So this impedance mismatch is kind of removed from the equation because data tends to be more denormalized by default. Using JSON, um, you can represent complex data types. So your object model and your data storage model are similar, if not the same. And JSON is just a special class of string. We're storing JSON straight into Couchbase, and this makes it very flexible. It makes it so that you can change your schema dynamically. There is no enforced schema in Couchbase, so it's a flexible schema, and that means from document to document, which doesn't exactly translate from row to row, but it sort of does. Um, it is sort of its own paradigm. So I'll make that translation, but that's only just the beginning. When you first get started with Couchbase, you think like that. You think in terms of, well, each row is kind of a document. But from row to row or document to document in Couchbase, the schema doesn't have to match. So you can have optional fields like address to or phone number to or second or third email address, and from one document to the next, that JSON key may not exist. And that's actually really powerful because what you can do is make schema changes on the fly while Couchbase is running. You can do it programmatically. You can be smart about it. You can do clever things. And you don't have to take Couchbase down in order to do any of this. And this is very powerful. It's very agile for development. You can, especially when you're creating a new application, you're constantly changing your data model. You're constantly your application data model. You're constantly changing all these things. And while you're changing these things, you don't actually have to worry about Couchbase at all because all you have to do is change your object model, and Couchbase, you'll be storing new data in Couchbase without having to do migrations and taking it down. So it's really very powerful. So we call the schema an implicit schema. Basically what that means is that your data model in your application is sort of implicitly defining your schema in Couchbase because you're storing it as JSON. And because the data is there and it does have a format, there is sort of an implicit schema there. So those are the primary differences right there between relational and Couchbase, and we're going to talk about some more. So this is the aggregate view of data, and again, if you've never read any of Martin Fowler's work, he's a great author. He's written a lot of great books about programming, and he talked about this aggregate view of data. So on the left-hand side here, we've got this web form. We've got this web form, which is actually composed of a number of different tables, data in different tables joined together in order to create this view. So this is an aggregate view. You're denormalizing your normalized data to produce this view and display it to the user. And with Couchbase, you tend to have actually the aggregate view already in the document. So in this case, I don't have to do the equivalent of joins. I actually have this sort of order, and it, when I pull that JSON document, I already have this sort of complex, data type where I have this array of hashes, and I have the payment information as a hash, and so I don't actually have to go through the process of normalization and denormalization. I already have an aggregate view, so it translates directly into that web view. What this does is, because I don't need these joins, it's very it's more flexible, and it also is easier to distribute data. Because I don't need joins, I can actually spread these documents across multiple servers very easily. And that's one of the advantages of having more denormalized data and being able to represent complex data types in this JSON format, is that I can distribute data, and therefore I can reduce my latency, I can increase my scalability, etc. So in this sort of example, just to continue forward with this sort of theme, on the left-hand side, I have this Java class that has these complex data types in it. And in relational, like I said, it's more challenging because I have to, have multiple tables in order to represent this in my object, represent my object in the relational database. And I could use an ORM, and ORMs reduce complexity on the programming side, but you're trading off more complexity on the database side. Optimizing ORM queries is more challenging. ORMs are not typically very fast either. So you're actually making a trade-off here. You're making it easier to program because the ORM is doing all of the hard work, or all the grunt work of working with relational, and they're taking care of it for you. But then you've got the trade-off on performance. So when your application is more successful, you're going to have, to deal with, the problems of scaling relational. So with Couchbase, obviously, since we can store JSON, we can, represent this data type, this class very easily, in a single JSON document. And it's, pretty straightforward. It's much more straightforward than the relational version. And this is, really easy to do. The other thing that's an advantage of being able to store JSON is, like I was talking about, sort of modern applications. Typically we're getting JSON from all these different services, and one of the things that Facebook schema for my Facebook login, where I have to go through the entire JSON document, normalize it into multiple tables, pick all those column types, and all those relationships, just to represent the Facebook JSON, return results. That can take a really long time, and it's really painful. And if Facebook changes stuff, it breaks my, application. I have to, rework the schema, do a migration, etc. Like when you do a social login, you can, very easily, store that straight in Couchbase without spending a lot of time, creating and working on the schema. All right, so the benefits of JSON is some of what I've already talked about. It's a very simple notation. It's lightweight. It's very easy to read. XML used to be very popular. but it's very verbose, and JSON is much more compact, and it's much more easy to read. And also because, you know, almost everyone is now returning JSON, you know, with, you know, when you do integrations, then, you know, having JSON in your data store as well makes things just really easy. And then the serialization and deserialization of JSON is very fast and getting even faster. So because everyone is using it, so that's also one of the benefits of using JSON. So in Couchbase, the JSON document structure. So for the convenience of the presentation, we're going to just talk about all values as documents. Even if you store a straight string or straight number in Couchbase as a value, you know, and it's not JSON, it's just a value, we're going to still call that a document. So we're going to kind of group them all together just for the convenience of talking about all this stuff. So in Couchbase, we're storing all the meta information, includes the key. So we're a key value. We're structured as a key value store, so that ID, the meta.id, is the key for that document. And then we have revision number and flags. Those are used internally. The flags are used by the SDKs. We have the expiration, and then we have the type. And all that information is kept in RAM at all times, all meta information about each document. And then we have the actual document value, and that document value obviously can be the simple data types, or it can be JSON. And the document value, the most recent is kept on RAM, and if you're sizing your cluster to have all values in RAM, all of it will be in RAM. And of course, they're persisted to disk. So the typical workflow is like you have your object, you're serializing it to JSON, you're storing it in Couchbase, then you're retrieving that JSON back from Couchbase, and you're deserializing back into your user object. So this is the typical workflow you're doing. You know, for the people who are completely new to this, you know, it kind of helps to understand this is what I'm doing. I'm going to be taking my objects, translating them into JSON, storing them, retrieving them as JSON, and translating them back to the object. So let's talk about a few basic key patterns. These come up quite often, and they're very useful. The first thing is, since we are a key value store in terms of structure, is understanding that you're going to have, you know, to generate keys. Now, we don't actually create keys for you. There are other NoSQLs that'll create, you know, some unique ID, you know, type of scenario. We actually, you know, leave that up to the application developer, and there's a lot of advantages for that, because you can use those keys in creative ways as well. So every key within a bucket is a database, needs to be unique. So we tend to pick unique attributes, you know, for things like, you know, let's just talk about users. We pick unique attributes for them. So, you know, using email addresses, using usernames, using like SKUs or ISBNs. Don't use social security numbers or credit card numbers, even though those are unique. So we have basically kind of two different types of keys. We have what we call predictable keys, and that's where you can actually, they're human readable keys, meaning like an email address is a key. We understand that it's an email address and we can read it. And then we have what's called unpredictable keys, like GUIDs or UUIDs, and those actually, in order to find those documents, because they're not predictable, you need an index, a secondary index or views to find them. Or you can use one of a couple, one pattern that I'm going to show you, you know, in this presentation. So with predictable keys, it actually helps you. So like if the login for your website, for instance, is, you know, user has to type in their email address, you can actually, because they hit, you know, submit, you've got their email address, and you can check whether they're, you know, a current user or they need to, you know, sign up for your service. So, you know, having predictable keys can actually make that, you know, make that easier. Now, in the case of when you have, let's just say you could use, people can log in with an email address or username. In that case, you can either use a key pattern where the username translates into an email address, or you have to use a view, a secondary index, where you look up their email address by their username. So, you know, these are kind of the basic, you know, tenets of keying, is that you've got predictable and unpredictable keys, and they work slightly differently in terms of your process of using them. but I'd highly recommend using predictable keys whenever possible because it actually makes things very simple. So one of the first patterns I want to talk about is called a counter ID pattern. So we do have atomic counters in Couchbase. They're positive integers, and you can increment and decrement them. And this pattern uses an atomic counter as part of your key. So what we're going to do here is the first thing we're going to do is we're going to increment, whatever counter we're using for, like let's just say we call this is counter key, but let's just say we have user count as the key. We're going to increment that value, and when we increment it, we also get the new value back, and it's atomic. So we're going to get the new value back, and then we're going to use that value as part of the key for the data that we're storing. So this could be user 1001, and we're going to input the user data as the data. And so we're basically, this is almost like an identity column with with an integer, increment integer type pattern in relational. But we're in Couchbase, we do an increment on an atomic counter, and then we add that, we use that value as the key and add that data with that, as a component of the key. So this makes it easy to do several things. One is that you can also iterate through that collection. So if I do a get on that the atomic counter, I have the actual full count of the number of objects that I've created, with that counter. And so I can now, iterate through them. So if I'm using them for comments on a blog, I can just get 10 at a time, counting from count down, I get 10 at a time, and display those comment documents on the web page. So I have the entire, I know the size of the collection, so I can iterate through them because the key is predictable. I know the prefix is, let's just say user : and I know the suffix is related to the atomic counter, and since I know the full size, I can actually iterate through. So it is similar to the identity column. It's actually, a pair of operations where I'm doing an increment on a count, and then I'm doing, creating the data using that that atomic counter value that I get back after the increment. So that combination creates that counter ID pattern. Then there's another pattern here. It's called a lookup pattern. And lookup pattern is basically to have multiple ways to get to the same data. So here what I'm doing is I'm using a randomly generated ID, and I'm adding this document to Couchbase. Let's just say this is a new user I've created, and I'm using a random ID. But I also create these what's called lookup documents. And the value of these lookup documents is the primary ID of the primary document. So I have that primary document was the first operation, and now I'm creating this other document that's simply, the value is simply the key to the primary document. So now I can look up by email address, and here I can also look up by username. So now I've got two different ways to use key patterns to get to that primary document. In the data retrieval, I can get by email address, and when I get the email address, I actually get the primary document key as the value, and then I do a get on that, and I get the primary document for the user. So this is called a lookup pattern, where I'm creating multiple documents to get to that primary document. So we're creating a simple document that has a referential data. So I create that primary document, and then I create the lookup document where its value is simply the primary document's key. The lookup documents don't need to be JSON, especially if there's only a single primary document. If you have like a scenario, and I've seen this scenario where they actually have, a particular user can actually have multiple accounts, then it could be JSON, or it could be a string with a delimiter, so I can actually look up several primary documents. And it requires two get operations to get the data. First is getting the lookup, and the second is getting the primary document. What's interesting about this is that it actually does scale quite well, and I'll show you why. So here is kind of an exaggerated example where I'm actually using the counter ID and lookup pattern together. I have this user count on the left here, And then I have the primary document. It's keyed based on that that count. And so there's a primary document with all the the user data. And then on the right-hand side, I have a Facebook ID lookup. I have a Netflix ID lookup, a Twitter ID lookup, 2 email address lookups, and a username lookup. So I have all these different ways to get to that primary document without a secondary index. I'm just using a key pattern here. I'm using the lookup pattern and the counter ID. When you combine the two together, what you've got is this ability to, first you're going to do this increment. You're going to use that ID to create the primary document, and then you also create these, 2 lookup documents here that also, use that ID as the value. So what I know here is that I actually have 2 advantages. One is that I have different ways to get to the primary document, and I also know the entire size of the collection, so I can iterate through them. And so that's kind of useful in many cases to have a combination of the 2, where I can look up and I can iterate through. Data retrieval, no matter how many users you have, is still that 2-step process. You get the lookup document, get the primary document. So what are the pros of this? I mean, the pros of using these key value patterns is that all these operations are basic CRUD operations, which are over a persistent binary socket, so they're sub-millisecond responses, and it's overall much faster than the view queries on indexes, because you're going directly to the Couchbase nodes that are responsible for each of these keys, and you're basically speeding up your operations considerably instead of querying views, because these are just single operations. Gets and sets are very fast and trivial. And you're creating the advantage of having several ways to get to a single document, and it's always consistent because it's coming from RAM. We have that read your own rights. We don't have eventual consistency like you have in views and secondary indexes, and because they're binary, this stuff is going to be very fast. One of the cons is that you're increasing the number of documents, therefore, because you have these lookup documents, you're increasing the number of documents, so you have more metadata usage in RAM. So, you're going to have your 56 bytes plus the length of the key. And for most people, this is a non-issue, but I want to mention it that you are increasing the number of documents in Couchbase per user. If you have 2 lookup documents, you're also increasing the number of documents per user. And I do recommend using key patterns for users. That tends to be the largest collection of items, in your application, and also the ones that you want to be the fastest. You want the login and the registration, login, etc., to be extremely fast. It's important, and using key patterns for that is actually very useful. And I do recommend for people that are new to Couchbase to come to Couchbase 104 when we talk about views, so you understand, how secondary indexes work architecturally, so you can understand the difference between what I'm talking about and why I would use a key pattern versus a view for certain things, especially like user registration and things like that. So here's kind of the sort of correlation between relational. Here on the left-hand side, you're creating this table with an identity column, with a primary key, integer identity column, and then you've got each of your columns for each of the data items, and then on the right-hand side I've got this atomic counter, and then I have a primary document and 2 lookup documents. So when I kind of look at those 2 side by side in terms of the process, when I'm creating a new data item in relational, I'm doing an insert into, and then when I want to get a user by Facebook, I'm selecting with a where clause, Facebook ID equals, or I'm getting by email, I'm doing a select clause, select statement with the where clause being the email address match. But the problem on the left-hand side is that as my data set grows, as the more users sign up to the system, this actually gets slower and slower. While on Couchbase's side, when I'm using these statements, yes, I have to do a 2-step process of doing a get on the lookup document and get on the primary document, but even as I grow, it actually retains the same performance characteristics, because I don't actually have to find it within a giant table, it's actually much faster. So that's the real difference between these two scenarios, is that as Couchbase, as your user base grows and your data set grows, Couchbase remains the same in terms of performance, while relational will get slower and slower. Let alone when you actually have to shard and deal with that stuff. You know, when you've already scaled up, now that's a nightmare in itself. So also you can have multiple documents in Couchbase, and here we're just kind of trying to introduce a concept so you understand that you don't actually have to translate everything into a single document. Even within a single object, you actually might find it advantageous for large collections to actually have multiple documents. So what I tend to recommend is sort of aligning documents to behaviors within your application. So on the left-hand side, I have this single document for the user that has all these different sort of user behaviors within my application in that single document. So all my shopping carts, all the products I've bought, all the games I've won, all the notifications I have, all in this single document that's going to keep growing. And then on the right-hand side, I kind of give an example where I'm using my base key for the user and appending a suffix on them to separate out data by behavior. The reasons for doing this would be actually more towards managing your development to actually simplify, and it's good for BDD and TDD to kind of encapsulate information into certain documents. And reduce the number of behaviors that can modify a particular document. If you have all the user behaviors, especially when you have a social application where other users actually will influence another user's document, you could have a potential of many different users trying to modify the same document at the same time because it's all encapsulated into a single document. When you separate things out by user behaviors, you can actually only having certain behaviors affect a single document and reducing the number of behaviors affecting that document. You also reduce the chance for race conditions, modifying the same document, etc. by doing this. So, I mean, this is just a concept to understand that, hey, you don't actually have to have a single document per user. You can break things out to reduce the complexity of modifying the documents, and you can use a simple scheme where you have a suffix on the key, that separates, all these different behaviors, but is still keyed on the primary user ID. All right, so I call this, kind of behavior-driven design, and the point of it is to actually reduce the number of user actions on a single document. It also allows you to, have smaller methods that modify, documents, and it kind of lends it to easier development. Yes, of course, you're also increasing the number of documents in Couchbase and things like that. So this is kind of where you're kind of figuring out where you might want to separate things out or keep things in a single document. The other scenario that comes up is when you have sort of what's called like an infinite list of potential items. Things like notifications or comments. Notifications could be in sort of endless list. And where you wouldn't want to necessarily have all a user's notifications all in their primary user document forever. This could actually lead to a very bloated document. When you have an infinite list, you could actually potentially reach the limit of a document of 20 megabytes. In those scenarios where you have infinite lists, it's actually much better to use like a counter ID pattern. So I actually kind of showed that at the bottom on the right. I have like this notification count, my current count of notifications, and then I have each notification keyed based on that count. And I can also kind of keep track. I can have another counter where I said user : :1 : notifications viewed, and I can keep a counter of all the notifications that have been viewed and only show the user the difference between the two. So let's just say they've only viewed up to item 50. I can display items 51 to 57 to the user because they haven't seen those yet, and increment my notifications viewed counter. So this is kind of an interesting pattern I can do to kind of keep track of what notifications have been seen, and now I have this infinite list of notifications, and I'm kind of keeping track of the total count and what they've seen, as this sort of running counters. So let's talk about modeling a user a little bit. But if there's some, oh, there's lots of questions. Let's answer a few questions, Franco, and then I'll continue on and I'll answer more at the end.
Yes, thank you, Jasdeep. The first question is about buckets. You mentioned the concept of buckets. Can you give us more details of what is a bucket in Couchbase for those that are new to the software, and when is appropriate to use more than one bucket for an application?
Well, that's actually kind of a tricky question. I mean, generally speaking, okay, so a bucket is a database. Um, so some of the things we actually can talk about that a little bit in the Couchbase 104. There is a multiple bucket scenario for secondary indexes, but generally speaking, a bucket is a database, and you probably store, most likely from almost 90 some percent of the people will just have one bucket per application. So one database. The features of a bucket means that you're basically, keys are namespace to a bucket, so they have to be unique within a bucket. And then your design documents and your secondary indexes are also namespace to a bucket. So each bucket is its own database, with keys and design documents and views and indexes all together.
Great, thank you. We have a question, actually it came a few times. So can we do a bulk insert or updates on Couchbase?
Actually, some of our SDKs do have multi-set. We don't have like a bulk tool. Most people just write their own because they also want to determine, what format and keys and stuff that they want to use. We do have a command line tool called CB transfer that can read JSON files off disk and insert them into Couchbase. It's included with Couchbase. It's called CB transfer. But those are basically the tools. I mean, they're also using our SDKs as well to connect to Couchbase and run the operations. So they're really not too different from just writing your own. I do recommend, if you have a huge amount to load, try and figure out a way to chunk it and do it in parallel, and use kind of the fastest, language VMs like Java or C or C++. The Ruby virtual machine in general is slower and single-threaded. So you might want to, if you have a lot of documents, you might want to, think about, parallelizing it, chunking it, and using the fastest, sort of language VM like JVM or something like that.
Perfect. Thank you, Jasdeep. We have a few more questions, but we can leave some time at the end for those.
Okay. Okay, so modeling a user. Let's kind of talk through that a little bit. So one of the things that I like to say is, it helped me when I was moving from relational, a couple of years ago, is that data is data regardless of the form that it takes in the database. I'd grown so accustomed to normalization in tables that was how I thought of data. But actually, my objects don't care where the data comes from. Once it's populated, I'm actually working with the objects itself in my application, and I'm not really worried about how it's stored on disk. And in Couchbase, data is denormalized much more of the time. Not always. Sometimes you have what's called references to other documents. They're not joins, and there's no referential loading or within the SDKs where it automatically loads a reference. But you will have references to other keys. Like if I have a list of products and a shopping cart, for instance, I'll have keys to those product documents, and I might do a multi-get and pull all those products out, in a multi-get. So you do have references, but they're not like joins or anything like that. Of course, you're going to need references for certain, design. You're going to want to store, documents separately, so you'll have references to other documents, by putting the keys in a list or whatever. So the NoSQL paradigm shift is structural. It's not actually the data. You're still storing pretty much the same data. You're just changing how you think about that data, and you have much more flexibility in the schema, and you have much more scalability and speed. So this is the sort of user object, on the left, I picked Java this time, and on the right-hand side is the equivalent relational. I'm creating, a table with, these properties in it. in Couchbase, what I have looks more like this. I actually don't have to do a create table scenario at all. I actually just store it as JSON straight from the user object. So when I'm programming, this makes things a lot faster because I actually don't have to worry about doing any work on the database side. I just store my user object, and it's already JSON and translates back and forth. Marshal, demarshal, or unmarshal, or serialized, deserialized, whichever terminology you prefer. And then I want to add some things to my model on the left-hand side. I'm adding some things to my class. Now with relational, I have to take the database offline, execute this change, maybe a migration, and then bring it back online. But with Couchbase, I actually don't have to do anything. I just have added it to my model, and the next time I save that user, it's going to have those new properties. So I actually, this is very powerful because I've saved a huge amount of work already, just because I can just sit there with my model continually develop without having to do a migration. And so this is really awesome. I mean, I've been able to develop models in a fraction of the time because of I use Couchbase. So now we're going to add some complex data types in here. Now we have the sort of favorite colors is this list. So I have to do not only that, taking the database offline, but if I want to just alter this single table and include it, I actually have to be able to encode and decode from an array list into a single column on relational. So I have to do this work in my class that's specific to storing it in a single column, and so this is complicated for me. I have to add a bunch of code for this and make sure it's deduped and all that stuff. But in the Couchbase world, I'm still in the same place. I actually don't have to do any changes here in Couchbase side. I basically added that array list, and it's going to be serialized into JSON automatically. And actually, I've saved myself a whole bunch of work and decision work. Now I'm going to add some more, complex data types to my class. And in the relational, I know that this is going to be too big for a single column. So I'm going to create this second table called products viewed with a foreign key, and then I have to do these joins whenever I want to retrieve a user object and the products viewed. I have to do this join, this complex join between these two tables in order to pull those over. So now I have to make the decision to sort of normalize this and do this, migration, database offline, etc., bring it back online. With Couchbase, I don't have to do anything because that denormalized form is already there. The only thing that might be different is if I have this infinite list, I might want to use a counter ID pattern, in which case, I do things a little bit differently, and that's the multiple document scenario, where in my method for saving, I actually translate that over into an infinite list using a counter ID pattern because that's what I want to do. So that's one little difference there. If for most complex data types, as long as it's not an infinite list, I might actually just have a single document. But in an infinite list scenario, I might actually want to do something a little bit more specific. So the user IDs, we talked about the different patterns you can use. You can also use UUID, GUID, Snowflake, Twitter Snowflake, and other things. You can use lookup documents in combination with that. Use the email address as the username. It's pretty typical these days. Now, actually, there's only a few sites that actually have usernames, mostly forum sites. And so there's all those different ways to key your documents. Also, if you only use social login like Facebook, you can actually use just the Facebook ID because it is unique as well, or the Twitter ID, or whichever, or GitHub ID. And because those are going to be unique as well. And if that's the only way people log into your system, you can do that. And of course, you can still combine it with lookup documents and things like that if you want to have multiple ways to log into your application. You can also use views to get to user document keys. And you should come watch Couchbase 104 if you're new with views. And indexes are eventually consistent. And so that's important to understand. When you're creating new data, it's eventually consistent, so that means it takes a little bit of time before it's in the index and queryable, and we'll talk about that in Couchbase 104. And then with the key value patterns, you're going to have that immediate consistency. They're generally faster because you're just doing single binary CRUD operations. And of course, you can always have views in secondary index on top of your key pattern as alternate ways to get to user documents. So even if you use the key pattern like a counter ID or a lookup pattern, you can also still write views and index those documents. So you can use the combination of the two as well. So we're going to talk quickly. I know I lost a little bit of time with the audio, so I'm going to kind of talk through this quickly. This is the patterns that we were talking about, more visualized. In this case, I'm doing the lookup pattern. I'm getting the first document and then getting the primary document. I'm getting the primary document and the products viewed, and then doing a multi-get on that array list to get the actual product list. Let's just, if I have like an array list of product documents, I'll have a two-step process. First, I get the user document with the products viewed, and then I do a multi-get on the products viewed and get the actual product documents. So that's the case where I have a referential IDs within my user object. I have referential IDs in the JSON and my user object, and I'll do a multi-get when I actually want the actual product documents. So in this case, it's another step process where first I'm getting the counter ID and lookup. So here I'm getting the lookup key from the email address. Now I've got that it's ID 505. Now I'll get the primary user document, and that'll actually have the products viewed within it. And so then I'll do a multi-get with those keys. So that's the kind of combination of patterns and multi-get. And in relational world, you tend to feel like, hey, I need to avoid hitting the database as much as possible because everything is going to get slower and queries are slow, and I need to avoid hitting relational, and try and get as much data as I can in one go without having to do it multiple times. And with Couchbase, these operations are so fast, these CRUD operations are so fast that generally speaking, you have a lot more gets and multi-gets and things in a row where you're doing 2 gets or 3 gets in a row, and it's so fast that it becomes trivial. And that's one of the things you have to get used to with Couchbase when you're moving from relational, is that you don't really actually have to avoid hitting Couchbase. Of course, you can reduce the operations you do by being smarter or efficient, but having multiple gets in a row is not something you actually have to avoid at all. So that's actually leading into this slide, which is the mental adjustments, is that we tend to think if we're coming from relational and Couchbase is new and NoSQL is new, we tend to want to avoid the database as much as possible. But because these gets and sets are over a persistent binary connection and they're sub-millisecond coming out of RAM, it's so fast that having multiple gets is trivial and it's not something you need to avoid. Key design is also very powerful and useful because it allows you to creatively find data. You can use sort of in a notifications system that you have, like if you have future notifications, like I need to send a push notification 12 hours that my farm things are ready to be collected. I want to notify the user in 12 hours from now that hey, come in back to the game or whatever it is. You can collect your stuff. I can actually create basically a timestamp system where I use the timestamp of notification. I have like 1 document per minute in the future, where I have these workers that actually, I have 1 worker that polls those documents every minute, says, hey, here's a list of notifications I need to send out for this minute, and it takes all those notifications and puts it into another queue where these dumb workers just send out notifications over email or push or whatever. So this is where I'm using creative keying, where I have like this, sort of timestamp, 1 per minute, this JSON document with a list of notifications that need to be done, or basically a list of jobs are within this JSON document 1 per minute, and I have this one process that is polling once per minute for jobs that need to be done, and then it sends the jobs to a queue, and then I have all these workers processing these jobs. So this is very powerful. Keys are a very creative thing that you can use for lots of different scenarios. All right, so just in summary, we're basically, the difference between relational and Couchbase is you have either complex joins on the left where you cannot separate your data onto multiple servers very easily because they need to be joined together. The tables have to live together. And then as the data grows, it gets more and more expensive and it gets more and more slow, more difficult. And then on the right-hand side, we've got Couchbase where we have multiple gets and performance remains even as the data grows. And that's actually the key advantage of using Couchbase over relational, is that you can grow your cluster, grow your scale, grow your data size, and your performance remains even. All right, we made it through it. So let's take the last bit of time to answer as many questions as we can, and any questions I can't get to, I will answer on my blog post.
Perfect. Thank you, Jasdeep. Yeah, I just sent to all the attendees on the chat the link to both Couchbase 104, which is coming up on Thursday, and Jasdeep's blog, where he answered all the questions that we're not able to answer live. Is the link you can see on the chat as well. Okay. So let's start with the first questions here. So from your experience, what is the best way to ensure as much as possible that an item is referred with the same name throughout the database?
To ensure as much as possible an item is referred. Okay, I think I understand. Basically, what you're asking is how do I create a solid keying scheme so that a particular document's key has referential integrity, basically. And that actually has to do with your kind of keying scheming and making sure that you have good logic in your keying, and also picking a unique value that is immutable. Like by using a lookup pattern, for instance, I'm actually creating a primary document key that is immutable, and then I have these lookup documents that have mutable information. Like, let's just say I change my email address on the website, and I'm logging in with email. What I'm changing is I'm removing one lookup document and adding another, but the primary document key is still immutable. So if I'm using referential information, like I'm looking up comments by a particular user, or it's based on the immutable information. So that's sort of the strategy there to maintain referential integrity, is use immutable things.
Thank you, Jasdeep. I think we have time for one more question since it's already 11. Okay. From John. Sorry, there it is. So for the predictable incremental keys, what if you miss a few of them? For example, you generate the key, but you do not complete the write.
Well, then you'll have gaps in your counter, right? But that's actually okay, because you can, when you're doing multi-gets, you can have null values in there. Let's just say you're using it for comments, for instance, and someone later deletes their comment. Like, even if the write didn't succeed, let's just say that sometime later, someone deletes their comment, from the list of comments, which is pretty much the same scenario. You have a gap within your collection. When you're doing your multi-gets, you can actually have null values within that while you're iterating through. That means that comment was deleted. And the same goes for creating a new user. If for some reason your write didn't succeed and you didn't know about it somehow, then you'll have some gaps in that. But as long as you never decrement that counter, so if you're using a counter ID pattern, you never want to decrement that counter. It's not going to be an issue, because the counters are atomic and you're always incrementing. Even if a one doesn't succeed, you'll still be incrementing, so it's okay to have gaps within the counter. But then, if you really need it, like in the most accurate count of users, you can also, if you have a gap within the counter, you can have another counter that has the number of missing items within it, and then you can subtract the two if you need the perfect count. Of accurate account of how many objects. But generally speaking, it's okay to have gaps within that. I use this pattern a lot, and comfortable with having those gaps. And when I'm iterating through and I want to make sure I have 10 things at a time, like if I want to display 10 comments at a time and I want to ensure that even if deleted comments get displayed, I always have 10 even if there's deleted comments. I'll just get 15 instead of 10, and the chance of having 5 missing is very low. So then I can just still show 10 at a time, even if there's gaps. So there's ways around kind of having gaps.
Great. Thank you again, Steve. So that's all the time we have for this session. Again, all the questions we haven't answered live, Steve will answer on his blog today, and tomorrow we'll send the link to the blog together with the video and slides. And if you have other questions during this day, feel free to email us at webinar@couchbase.com or juststeve@couchbase.com. And don't forget to register for Couchbase 104, which is on Thursday. Thank you, everyone, for attending today, and I hope to see you on Thursday.
Thank you.